Good morning everyone. My name is Mohammad Zuhair Ahmed and I am currently a first year BTech student studying in computer science and engineering. Today's my topic on the course matrices and calculus is solving linear programming problems using the Simplex method for material allocations in manufacturing. First of all, what is linear programming? Linear programming is a mathematical optimization technique used in manufacturing to allocate resources most efficiently. Think of it as a decision-making tool that helps companies answer questions like how many units of product A and B should we make? How do we maximize profit with limited materials? How do we minimize cost while meeting demands? It helps manufacturing maximum profits or minimize costs while satisfying constraints. The simplex method is a popular algorithm for solving these programming problem efficiently. It is systematic, efficient, and guarantees finding the optimal solution. How to formulate a material allocation problem. Step 1 is identify decision variables for material usage. Example, what product can we make? What are we making? How many of each? Step 2, establishing constraints. From resource availability, material constraints 2x1 plus 3x2 less than or equal to 100 kg for example. Step 3 is define objective functions which maximize profit. Step 4 is convert to standard form, change in inequalities into equalities using slack variables. Mathematical model reading. Now we can apply the simplex method. Overview of simplex method. The simplex method iteratively moves towards the optimal solution of a linear programming problem. It uses feasible solutions and improves them step by step based on objective functions coefficients. The method continues until no further improvement is possible. Setting up the initial table. Organize all your equations and objective functions in a table. It's also called as simplex table. Row equals to constraints plus objective functions, and whereas columns equals to decision variables plus slack variables plus solution. The iterative process. The simplest algorithm works like climbing a mountain. Start a basic feasible solution, finding the entering value, which variables should be increased to improve profit. Like look for the most negative coefficient in the objective function row that tells us which variable helps most. Find the leaving variable which current variable should be decreased. Like use the minimum ratio test and don't violate any constraint. Perform row operation to recalculate the table. Repeat. Keep going until no negative coefficient remains. Basic components of linear programming problems. Decision variables represent quantities to be determined such as material amount. Constraints define the limitations like resource availability and product requirements. The objective function qualifies the goals such as maximizing profit or minimizing cost. Formulating a material allocation problem. Identify decision variables related to material usage for different products. Essential constraint based on resources availability, demand and production limits. Define an objective function to optimize such as minimizing material cost. Example for scenario setup. Consider a manufacturer producing two products with limited raw material supplies. The goal is to allocate materials to maximize profit or meet demand efficiency. Constraints include material availability, machine capacity, and production requirements. Constructing the mathematical model, like variables x1 and x2 represent quantities of product 1 and 2. Objective function maximize z equals to c1 x1 plus c2 x2, where c1 and c2 are profit coefficients. Constraints include inequality representing resource limit and non-negatively conditions. Conversion of simplest method to standard form. Convert inequality constraints to equalities by adding Salk variables. Ensure all variables are non-negative for the simplex method. This standard form facilitates systematic solution procedures. Setting up the initial simplex table. Write the objective functions and constraints in table form, including slack variables to the transform inequalities. Identify the initial basis feasible solution for the iteration process. You can refer to the given diagram. Performing the simplex algorithm setup. The graphical method of solving linear programming problems is useful only for problems involving two decision variables and relatively few problem constraints. Select the entire variable based on the most negative coefficient in the objective row. Determine the leaving variable using the minimum ratio test. Pivot to update the table and move towards optimality. Iteration process and convergence. Repeat the pivoting process until no negative coefficient remain in the objective row. Each iteration refines the solution close to the optimum. The process guarantees reaching the best feasible solution under linearity assumptions. Optimal values of x1 and x2. For example, produce 25 units of product 1, 18 units of product 2. Maximum profits or minimum profits. Cost. Example, maximum profit is 2270 rupees. Slack values. So unused resources. Example, S1 equals to 5 kg. Do all constraints get satisfied? Yes. Interpreting the final solution. The values of decision variables at optimality indicates material allocations. The objective function value shows the maximum profit or minimum cost. What does the final table tells us? After iteration stops, you have optimal values of x1 and x2, maximum profit or minimum cost, slack values, practical consideration, data accuracy, garbage in, garbage out, profit coefficient and material requirements are crucial. Sensitivity analysis. What is demand drops? Sensitive analysis show impact on optimal solution. Software tools, benefits, limitations. Practical consideration in manufacturing. Data accuracy is crucial for reliable model formulation. Sensitivity analysis helps understand the impact of change in parameters. Implementation requires software tools like Excel Solver or specialized LP software. Benefits of using the simplex method. The simplex method is a powerful tool for solving linear programming problems because it is both efficient and effective. It has been shown that to be faster and more accurate other methods, making it the preferred choice for many applications. One of the key advantages of the simplex method is its ability to handle large-scale problems. When it's iterative approach, the simplex method can quickly converge one of the optimal solution, even when dealing with complex systems. Provides a systematic and repeatable approach to resource allocation, helps identifying bottleneck and optimize resource utilization, support decision making for the complex manufacturing. Limitation and challenges. Linear programming assumes linear relationships, which may not always hold. Large problems can become intensive. Model assumptions may oversimplify real-world manufacturing complexes. Other limitations are large problems can be computationally intensive, oversimplified some real-world complexes. Future trends in material allocation. Integration of linear programming with AI and machine learning for dynamic decision making. Use of real-time data to adjust allocations and optimize operations. Develop of more advanced algorithms for large-scale manufacturing problems. Summary. Formulate the problem with decision variable constraints and objective. Convert to standard form and set up the initial table. Apply the simplex method iteratively until reaching the optimal solution. Conclusion. The simplex method is a powerful tool for optimizing material allocation in manufacturing. Proper formulation and understanding of constraints are essential for effective solutions. Combining LP with modern software enhances decision making and operational efficiency. Thank you everyone for listening my presentation.